Relative molecular mass. Relative molecular mass of a compound is calculated by adding the relative atomic masses of the respective elements that made up a compound. Don't forget that a compound is formed when two or more elements are chemically combined together. So if we are talking about relative molecular mass, the way you can find or calculate the relative molecular mass of a compound is by adding the relative atomic masses of every element inside that compound. For instance, if you are asked to calculate relative molecular mass of this compound, it's a compound because it has three elements: calcium, carbon, and oxygen. And if you are lucky, the examiner will give you the respective atomic masses. But if you are not lucky, you need to know them. Like that of calcium, the relative atomic mass is 40. Please don't confuse it with the atomic number of calcium. Atomic number of calcium is 20. But if we are talking about relative atomic mass, which is the sum total of the proton and the neutron of an element, that is what 40. Calcium is 12. Oxygen is 16. In case in fact, for today, and these things are fixed, whether you are watching from UK, USA, Nigeria, Dubai, anywhere you are, these values are fixed. It is not like the weight of a substance which varies, but this one is the same thing worldwide. Relative atomic mass of calcium is 40 anywhere you go. That of carbon is 12 and the oxygen is 16. So if you are lucky, they will put it in parentheses, they will put it in brackets for you. So it is very simple. Don't forget that we are dealing with relative molecular mass. Now, let us calculate the relative molecular mass of this compound. If you remember what I told you when we are starting, I told you it is done by adding the relative atomic masses of the elements involved in that compound. So this one, calcium, relative atomic mass is 40 plus carbon is 12 plus oxygen is 16, but we have three molecules of oxygen there. If you watch, this three is only affecting oxygen and not carbon or any other one. So oxygen is 16 and I'm multiplying it by 3 because that 3 contains oxygen alone. So this thing now becomes 40 plus 12 plus 16 times 3 is 48. So when you add all these things, it will give you 100. That is what we call the relative atomic mass or relative molecular mass of this compound is 100. And don't forget that relative molecular mass has no unit, just like relative atomic mass has no unit. Remember, if you're talking about relative atomic mass, we are referring to one element. But relative molecular mass is talking about molecule or compound. Let's see further examples. Let us see example 2. Luckily for us, they are giving us relative atomic masses. They will always put it in brackets. They have given us relative atomic masses of the respective elements in those compounds. So let's check example 2 now. Sodium triisocarbonate 4. So relative atomic mass of sodium from the bracket we have given is 23, but we have 2 sodium. Don't forget, these 2 is affecting sodium plus carbon is 12 plus oxygen is 16. And you have 3 molecules of oxygen. That was why I'm multiplying by 3. Open the bracket. Now I have 46 plus 12 plus 48. 23 times 2, 46 plus 12 plus 16 times 3 is 48. When you add all this, it will give you 106. Relative molecular mass of this compound is 106. Example 3. They give us phosphorus. The phosphorus is 31. That is the relative atomic mass of phosphorus. It's 31. So the important thing here, there is no big deal about it, but it is just understanding the subscripts. Like this one now, if I want to start this one now, I'll bring out this three. This three is affecting this three outside the bracket, is affecting everything inside the bracket. That was why I brought it out here. So nitrogen is 14 plus hydrogen is 1, but you have 4 hydrogen there. Plus phosphorus is 31 plus oxygen is 16, but you have 4 oxygen molecules. Just follow it sequentially, you will get it. This three outside the bracket, the three is here, is affecting every other thing inside the bracket. But this four is only affecting hydrogen. If you can be able to understand these things, there is no big deal about relative molecular mass or even the molar mass of which we will do next. So add up 14 plus 4. Remember, 1 times 4 will still give you 4. Plus 31 plus 64. 16 times 4 is 64. Now open the bracket. 3 times 14. Okay, let's just do it this way. 14 plus 4, 18 plus 31 plus 64. Let's press our calculator. 3 times 18 is 54 plus 31 plus 64. When you add up, it will give you 149. Relative molecular mass of this compound is 151. Now the last one, example 4, iron 3 tetraoxosulfate 6. Iron 3 tetraoxosulfate 6. So if you understand the numbering, you are good to go. Iron is 56. 56 times 2. We have 2 molecules of iron there. Plus, I am bringing this 3 outside. Because it will affect everything inside the bracket. Sulfur is 32. Oxygen is 16, but you have 4 oxygen there. You have 4 oxygen there. So this is 56 times 2 will give you 112 plus 3, 32 plus 16 times 4 will give you 64. Now let's 112 plus 3. This plus this will give you 96. And of which calculator will help us to do justice to that quickly. If you add it up, it will give you 400, which means relative molecular mass of iron 3 tetraoxosulfate 6 is 400. It is very simple. Quickly, if we are talking about molar mass, this should be another topic. If we are, okay,